Hello, future mathematicians. Welcome to CMAPEC. Now we are doing example 4, f of x which is equals to negative 2x squared. But it is restricted where x is less than 0. It means the domain of this function is negative infinity until 0, or x less than z. So how do we determine the inverse? And take the perfect one. Therefore, we know y is going to be negative 2x squared. Therefore, interchanging x and y give me negative 2y squared. Dividing by negative both sides, negative 2, we are left with x over negative x over 2. Here all squared. You take the square root. If you take the square root, it's going to be plus or minus the square root of what? Negative x over 2. Then we have the inverse of f of x, which is equals to plus or minus, but we want the correct one. So when we check the restriction, x must be less than 0. If x is less than 0, it means y also need to be negative. So we take negative the square root of negative x over 2. So the answer that we must get for y needs to be negative. So now, how do we draw it? Draw the inverse, original and its inverse. This is x-axis and this is y-axis. Y, this is x. So when we check the f of x, is this one is said, suppose it's supposed to be like this. But there is a restriction. We're saying the x must be less than 0. It means we have to erase where x is positive, this part here. So here is the function. So now, what is the inverse of f of x? So we said it needs to be also negative. It must be at least below here. So when we check here, it's negative, negative. If you interchange negative and negative, the graph will look like this. The inverse function is going to look like this. But suppose if there was no restriction, should be looking like this. It's not fair enough. Let me draw the perfect one. Fair enough. So it's supposed to look like this. But since the domain of the original is less than 0, it means even the domain of the inverse must be x less than 0 and the range as well. So now we erase this one, and then our graph start there. So you need to also indicate the line y equals to x. Yes, the line y equals to x. Almost perfect, but it's not perfect. Almost perfect, but it's not perfect. So it must be passing through here and this point. So here's the line y equals to x. Y equals to x. And then this is f of x. This is f inverse with that restriction. So the domain of f, x is less than or equal to 0. The range we can see is y lesser than equals to 0. Same applies with the domain of the inverse. F inverse x is lesser than or equals to 0, and the range y is lesser than or equals to 0. In some cases, they will ask you, is this function? We can see, oh, these functions are function because the vertical line tests touch at once. So we will talk about that when we get there, whether the graph is a function or not. Thank you for watching this video. Let's go for example number 5, the last example.